Okay, so up to this point, we've been doing a lot of work, ladies. We've been doing a lot of work with graphs, right? And being able to show that these number patterns that have specific relationships can be drawn on a graph. We talked about you use ordered pairs, right? There's an x value and a y value. We talked about the fact that that you have two axes, the x-axis and the y-axis, etc., right? So we haven't really used our graphing techniques to answer any questions or do much work, right? So today what we're going to do is we're going to look at how to use our graphing techniques or our graphs to solve equations. Guys? All right. First of all, can anyone tell me what makes something an equation?
When you have equal sign?
When you have an equal symbol, exactly, right? Anytime you see an equal symbol, you know you have an equation, right? Now, we're not worried about solving equations using traditional methods of isolating the variables, etc. We are specifically focusing on how to solve them using the graph. So don't make this harder than it is. All we're doing is reading from the graph, right? So, but you do have to pay attention. Am I solving? So they're going to give you a y value. If they give you a y value, then we can find the what? X value. Good. If they give you an x value, we can then find the what? The y value. Perfect. Okay? And that's all you're doing is going to be reading points from the graph. So keep it simple. Now what's important though is that you see how powerful this is for working with different types of information. These are really, really important pieces of information that you can use and ways you can solve lots of problems. Okay? All right. So, everybody ready? Let's go and see what's going on. All right. So, we can use our knowledge of relationships between linear equations and linear graphs to solve linear equations, right? Because remember that the graph is simply a picture of the equation. Okay? So if we know that those two things are the same thing, then we can use the graph to solve equations. Just like yesterday, we used the equations to make the graph, right? So you can work both ways. And remember, anything you can do one direction in mathematics, you can also do the other direction. Okay? All right. So we learned how to find the intercepts of a graph, but we only looked at one intercept yesterday. What was that intercept called? The Y-intercept. And remember, the Y-intercept is the place where the line is crossing the Y-axis. There you go. Well, if there's a Y-intercept, then there should also be an X-intercept, which is simply the place where the line is crossing the X-axis. Excellent. Boy, y'all are firing on all cylinders today. That's excellent. Okay, so it's any place where it cuts across the axis. Now, if it's on the X-axis, remember, that means you can't have gone up or down any. And which value, X or Y, tells you up or down? The Y tells you up or down, right? So up or down none means Y has to be what number? 0, exactly. Good. Okay. All right. And if on the Y-axis, just the opposite is true. You can't have gone right or left any. Right? We can go up or down as much as we want, but we can't go right or left any. So in that case, which value has to be the 0? The X, right? Because X tells you to move right or left. Good. Keep those in mind as we're looking at these. So, many times you want to find where X is equal to 0. And one of the reasons for that is that often that's where a graph begins. If you look at this particular graph, this chart, we're only interested in this section. And what we want to do is find out where this line starts in that section. Now notice it does move a little on the other across here, right? Okay. But what we're interested in, because they only gave us these two parts of the axes, We're only interested in that quadrant, is what it's called, that section of the graph. Quadrant means that it's divided up into how many equal parts? 4, right? And if you think of a graph, it's always divided into 4 equal parts. So we're only interested in where the line starts. And so the line starts on the y-axis. Do you see that? It's right there. Now, if that's the case, then on the y-axis, what does the x value have to be? 0.
0.
Right? Because when you start something...
On the y-axis, it's got to be 0.
You're going to be on the y-axis and it's going to be 0. Because when you start something, have you done any of it?
No.
No. You're just beginning, right? So you've done nothing. So in this particular case, this is time. When the race starts, have they spent any time? No. So the time is 0. So it's very important to understand where those starting points are. Okay? Excellent. So it's a really critical point to know. So to find the value of y when x is 0, that's just simply the what intercept? Y-intercept. If x is 0, that's the value of the y-intercept. So in this particular case, you'll see that he's pointing toward where the y-intercept would be, right? Okay. Oh, and I wanted to mention something else here too. Notice that they don't give you any numbers on the number lines. Anytime that's the case, you can assume they're moving 1 unit. But does it always move 1 unit? No. So be very careful. So say they had said that's 10, then 20, then 30, etc. Then they're counting in tens. Each line represents 10. Remember yesterday we had one where they were doing it in 2s. So pay very close attention to the scale when you're reading these. You're solving these, okay? Because it can change.
I'm writing it.
Okay? All right? So just make sure that you pay close attention to the scale of the graphs. All right? Now, we can use the information from a graph to solve an equation. For example, here is an equation. How do I know, first of all, that this thing is an equation? Because it has an equal symbol in it. Good. Okay? If that's the case, then we have our y value, we have an x value, right? And then we have a number at the end. So we could find our slope, and we could find our y-intercept and draw the line, but we don't have to because they've already done it for us. Okay? So we could have drawn the line, and later we will, but here they've already drawn the line for us. And what they want to, so we can use that line to answer questions about it. So, looking at this graph, you can see that the y-intercept, or in other words, the place where the line crosses the y-axis, is at what number? -2, -2, right? So the y-intercept is -2. Well, we also knew that from the from the equation, because remember that y-intercept is always going to be the number that follows the x term. Remember that from yesterday? So, 2 different ways we can get the same piece of information. Because usually they'll give us either the equation or the graph, not both. Okay? Good. All right. So, if that is the point at which it crosses the y-axis, what does x have to be at that point? What number? What does x have to be? 0, right? If you're on the y-axis, x must be what? 0. Can it ever be anything else? Absolutely not. If you're on the x-axis, y must be what? 0. Can it ever be anything else? No. Pretty darn easy, huh?
Yeah.
Pretty happy? Okay,
Yeah.
good.
No.
So here we have an equation. And what I want you to do is I want you to take a second look at it, and then I'm going to call on somebody to tell me what is the value of y when x equals 0. Just reading the graph, reading from the graph, what would it be? Don't call it out. Okay, are we ready?
Got it.
Does somebody? All right, who's got it? Okay, you guys have been asking questions, so go ahead. 2, positive 2. Exactly. Because remember, if x equals 0, that means you're talking about the y-intercept, right? Now, could I have gotten that same piece of information from the equation? Yep. It's the number at the end, right? Okay? But many times we're not looking for that specific number, so we use the graph. Excellent. All right? Okay? What is the y value when x equals 0 here? Just call it out, everybody. -2. Again, we know that because if x equals 0, we're talking specifically about the y-intercept, right?
Yeah.
Okay.
I'm so smart.
Excellent. I'm very pleased. All of you are geniuses. I am very happy with that. Okay. What is the y value here when x equals 0? 10. Positive 10. Good. I like that positive. That's good. All right? Okay, good. All right, here we go. What's the y value when x equals 0? -6. Did I tell you this was going to be easy? Did I mention that?
Yeah.
Good.
I get it.
Right? You're just doing it. Now, we can use that information to answer questions. For example, this graph is the height of land above sea level. We might want to know where the land is at sea level. And the y, which means at sea level, remember at sea level, that's not straight up and down, right? The ocean doesn't go up and down. What does it do? It's horizontal, flat, right? So is that the x-axis or the y-axis? The x-axis. So at sea level, if I'm reading at sea level, I don't want the y-intercept. I want the what? X-intercept. Okay? And here, so you can see, they don't give us any units, but you can see the point where the line crosses the x-axis is right there. Now, if we were just counting this as ones, that would be what? 1, 2, 3, 4, 5, 6. 6 what?
Meters.
Meters. Remember that we always have to give units. If the graph gives us units, our answer must have units. Yes. Okay, because of the information they gave us. It's sea level, right? Does the sea go like this? Does the sea go like this? Yes, and that's how. So sometimes we just have to get it from context, but we can also get it from this fact. Sea level is where y equals what? 0. So they gave it to us as a number value, but I also want you to think about it. You can get it from context. So, if I want to measure, if I'm talking about a point on a wall, what am I talking about? Y-axis, because walls go up and down, right? If I'm talking about a point on the floor, X, because that's horizontal. Okay? So sometimes you can get it from just context. Good. All right. So any point where y is 0 is going to be on the which axis? X-axis. Have they said that a lot of times?
Yes.
So do you think it's important?
Yes.
Yes. It's really very, very, very important. As you move forward in algebra, you're going to see that those 2 points on a graph are critical points. They're very important to know. And so the better you know it now, then later when you see it, you'll understand it better. Okay? All right, here we go. Solve it for y equals 0. So where is y equals 0?
Are you sure? No. 6.
Positive 6, right. Y equals 0 is the x-intercept.
Yeah.
So y equals 0 is the x-intercept, not the y-intercept. So be careful. And then see again where that's why I mentioned it so many times, because it's so easy to get them backwards. Okay? All right. So there you go, showing you the y-intercept. I'm not quite sure why he's wearing a hat, but there you go. Okay. Okay. All right. So look at this graph, guys. What is the value of x when y equals 0? 4. Excellent. Because y equals 0 literally means the x-intercept, and that's at positive 4. Okay? Oops. Because, oops. Okay. There we go. It's positive 4 because if y equals 0, that's the x-intercept, right? Which is right there. And that's why it's positive 4. Okay? All right. Good deal. So, I don't even have to answer the questions anymore before I get answers. That's good. All right, so in this one, if y equals 0, what does that make x? Negative 7. Okay? Are we happy? Okay? Y equals 0, what's x? Positive 1. Yeah, good. Okay. Negative 3. Be careful, yeah. You almost went with the wrong one. You're good. Y equals 0, that's the x-intercept. Good. Okay? Now, look at this one. So here we have a graph, okay? It has a y-intercept, but does it have an x-intercept? No. And one reason it doesn't have, guys, it doesn't have an x-intercept is because we're measuring time, okay, and height of a plant. So let's look at the question. Beatrice is growing a kelp plant in her underwater garden. The graph shows the height of the plant over a period of 2 weeks. How tall is the kelp plant after 6 days?
8 meters.
Yeah, if you look at the graph, days is the x-axis, right? So 1, 2, 3, 4, 5, 6 is right there. All I need to do is go up from there and find out where that line intersects 6, and then read across, and it is how high? 8 what? Centimeters. Remember, when you're answering questions with units, you must include the units in your answer, or it'll be wrong. Okay. No, yes, it's on. Well, you're just reading the numbers, but the point that you want is right here, right? What's the y-intercept here? 5. Okay. So that means that the plant started out how tall? 5 centimeters.
So like they bought it at 5 centimeters.
So when she bought it, it was 5 centimeters tall, and then it started to grow from there. Good. Excellent. Okay. So there they show you drawing the lines, and then, guys, and then showing where the lines intersect. Remember that drawing tool. Why are their computers open?
Oh, sorry. I just have an outfit telling on my computer.
That's fine. Then you don't need to look at it to see it.
Yeah.
All right. So that drawing tool on your Education Perfect will be good for drawing those lines.
It's just necessary.
So, all right. So, all right. So all you're going to be doing is just reading those points. Now, I want you to look at this graph because I want you to notice the equation is here, but am I using the equation while I'm to solve this?
Yeah. No.
No. All I need to use to solve it is the graph.
Yes.
Right?
Wow.
Okay?
Yeah.
So, why do they put the equation here on that line, though?
So that you know the formula.
Well, kind of. It's because that's the name of the graph.
That's a really... because that's what the graph is. Because
Exactly, because...
From that, you'll be able to draw the graph.
Right. And so you always need to name the line. So that's why you'll see the equation on the graph.
It's like
okay? So when y equals -6, where does y equal -6? Guys? Yes? Yes. Did you have a question?
This is another question. If there was a graph like that, but it didn't say like y equals 0 or x equals 0.
Y equals -6.
If it didn't say that, how?
Where does y equal 6? Not answering my question. Where does y equal 6?
+2. No, positive. What?
Where does y equal 6?
-9.
No, positive.
Y equals 6 where?
-6.
Down 6 on the y-axis. There you go. There we are. There. Answer my question. Answer my question. Y equals 6 where? on down 6 on the y-axis, right?
Well, then wouldn't it always be negative 6?
No, hold on. But we're not answering the question. You're not listening to the question. I'm not asking you to tell me for this equation where does y equal 6. I'm just saying where does y equal 6. You're jumping ahead of me here. It just means down 6. Well, if I go down 6 and then go and find out where it crosses that line, where does it cross the line?
Is this just a coincidence, or is it like
At 1. So hold on just one moment. If y equals negative 6, what does that make my x value equal?
Negative 3.
I don't get this.
Then why wouldn't it just be 6? Because it's negative 6.
Because, hold on. Hold on. Listen to my question. Hold on. Okay, all right, so focus. Where on any graph on the whole planet does y equal negative 6?
Negative 6.
Down what?
6.
Down 6. So let's just go down 6 is right there, right? So all the way across is where it equals negative 6, right? Well, if we're at negative 6, we need to go which direction to hit the blue line?
Right.
To the right. How many?
1.
So right there is where we hit the line. And so that means x equals 1. Right? Okay?
I don't get it. Doesn't x equal 3?
Why would x equal 3?
Because x equals... Because
The x-intercept is 3.
Oh, wait, do you mean...
I'm not asking for the x-intercept. I'm asking what is the line doing when...
Shut up.
Yeah. Hold on. Okay? We did exactly the same thing. Remember, if I put a dot here and I asked you to tell me what is the x value and the y value for that, all you did was count over to 9. So that's negative 9 because it's to the left. And then you went up 10. Remember that exercise? Yeah. It's the same thing, except you're going to be given one value, and you have to find the point on the line to be able to get the other value. Okay?
If you're trying to do you're trying to find the coordinates, do you do the y?
It depends on which one they give you first. If they give you y, then you're looking for what? If I give you y, if you already know what y is, which thing do you not know?
X.
The x, yeah. So, hold on, let me finish my sentences, please. If they give you y, then your job is to find x.
No, I mean if there's a dot on a graph, and you have to find the number, and you have to write it down, would you put the x value or the y value?
Both.
When the ordered pair, what does it always come?
X, Y.
Right, Charlotte, what does it always do? So the x always comes before the y. Remember, for ordered pairs. That's why they're called ordered pairs. Excellent. Okay. Let's look at another one.
Who's they when you say that's
know.
what they'll give you? Who are you talking
Okay.
about?
Whoever wrote the problem. Okay, here we go. Yes.
So if you said what is the line doing at negative, negative 5, and then you find the answer to that, would it be y equals the answer, or would it be x equals the answer?
Well, it depends. If they give you a y, then your answer is going to be an x value. If they give you an x, then you're looking through the one you don't have, right? So look at this one. Guys, focus here. All right, everybody look. Here I have a graph of an equation, right? And they say, find the solution when x equals what?
6.
X equals 6. So, do I know an x value? Did they give me an x value or a y value?
X.
They gave me an x. They tell me x equals what? They gave me x equals 6. Which means, if x equals 6, then what am I looking for?
Y equals 0.
The y. Right? If I've got x, then I'm looking for y. So where does x equal 6? To the right.
Minus 5.
No, just tell me. No, just tell me.
To the left, 6.
No.
No, to the right.
X equals 6 to the right 6. I'm not talking about on the line. I'm talking about if you were graphing X equals 6, what would that tell you to be doing? Go to the right 6 spots. Right.
So you can't just graph
Okay.
6.
So that is the line that I'm talking about where X equals 6, right? Now, all I need to do is find out where does that line hit my blue line? Right there, right? Which is -5. So if X equals 6, what does Y equal? -5. There you go. Don't make it harder than it is. Okay. All right. I'm doing your homework for you there. Okay. Now, sometimes you're going to have areas when you solve. So if you have y equals 3, in order to solve that, you have to have the graph, right? Do you agree? Right? So, but sometimes you're going to have to graph it first, and that's why we learned yesterday how to solve it, how to graph things using the Y-intercept and the gradient. So, remember, if you have a gradient of 2, we have to plot that as rise over what?
Run.
So if the gradient is 2, I have a rise, but what do I not have? A run. But that's okay, because I can make anything look like a fraction by putting it over 1. There you go.
What's a run?
Run means going across, right or left. Now, so 2 over 1. So 2 over 1 is my rise, is my gradient. And what is my y-intercept in this case, they tell me? 1. So that means plot a point at 1, and from that point count up to and to the right what?
1.
So up to and to the right 1,
Why up to?
because it's a positive 2. Positive 2 means go up 2, right? And there's your line. So that's how they got that line. Okay? So that's from yesterday's lesson, remember? All right. And then once you have the line, you can locate any point on the line. So here they want you to locate where y equals 3. Where does y equal 3? On the y-axis, up 3. I'm not talking about the answer. Just tell me where y equals 3. Y equals 3 means go where? Up 3. Maybe if I change the way I say it. It means go up 3, right? On the y-axis. So there's where I'm looking. So there's where it crosses, right? And that means x is equal to what at that point? 1. Okay?
Do you go up 3 because 2 plus 1 is 3?
No, you go up 3 because that's what they told you to do. Look at the question that they gave us. Hold on just a second.
Oh, okay.
They told us y equal 3.
Oh, okay.
So they'll always have to tell you one number or another number. Okay? All right. Okay. So, I'm going to do this assignment for you so that y'all can practice some of these. I want you to work on some of these and practice some of these here because I need you to understand what's going on. And I still think some of you are a little shaky. So we need to try it. Y'all are trying to make it harder than it has to be. So slow down a little bit.
Making it harder than it has to be.
Pardon me?
Education Perfect's making it harder.
No. All you're doing is reading and counting.
And
Okay. There's no math to do.
That's a very good word. Charlotte invented a word.
Mr. Smith.
There you go.
You must give me the time.
Pick a name, any name.